You ever just look up at the night sky and it's like, wow, all those stars just kind of stuck there like on a giant black sheet of paper?
Yeah, it is kind of like that.
But that's not really how it is it?
Not at all. It's a total illusion, right?
Yeah.
The universe is three-dimensional, obviously, but we're only seeing a tiny slice of it.
Right, we're getting a two-dimensional projection of this incredibly complex 3D structure. So it's like our brains are kind of getting tricked, and that can make things line up in ways that are just totally coincidental.
Yeah. We end up with these crazy cosmic alignments. Stuff that's actually billions of light years apart, looking all cozy in the same patch of sky.
Speaking of which, this new image from the James Webb Space Telescope, or JWST, is a perfect example of that.
Oh yeah, this image is amazing.
So today we're going to do a deep dive into this image and what it tells us about star formation and just how mind-bogglingly vast space really is.
So we're talking about a nearby protostellar outflow. It's like this jet of material shooting out from a baby star still in the process of forming.
And this one's called Herbig-Haro 4950, or HH4950 for short.
And in this JWST picture, it looks like it's about to crash right into this beautiful spiral galaxy. But it's just a trick of perspective like we were talking about. These two objects are nowhere near each other in reality.
So how are we going to break this all down today?
Well, first we're going to look at what this image tells us about how stars form, especially these Herbig-Haro objects.
Okay, those sound kind of intense.
They are super intense.
And then, what about the scale?
Then, yeah, we'll tackle the sheer scale of space that allows for these seemingly impossible lineups to occur.
So this is for anyone who wants to understand some pretty complicated astrophysics, but doesn't want to get bogged down in the technical stuff.
Right, we're providing the shortcuts, the big picture takeaways.
Awesome. Now, before we go full-on Webb, what exactly are these Herbig-Haro objects again?
Right, so they're glowing clouds of gas. They form when a brand new star blasts out these super fast jets of material.
It shoots it right out into space.
Exactly. And when these jets slam into the slower stuff that's hanging around the star, all that gas and dust, it creates shock waves.
So it's like a cosmic collision.
It's a head-on collision.
Yeah.
And those shock waves heat things up to crazy temperatures, like thousands of degrees.
Wow, that's hot.
Oh, yeah. And that's what makes them glow. They shine brightly at a bunch of different wavelengths, including infrared, which is what JWST is amazing at detecting.
So it's like these baby stars are having these explosive tantrums, throwing stuff out, and we're seeing the aftermath as these glowing clouds, like cosmic fireworks.
Perfect analogy.
Now, this particular object, HH4950, has been seen before, right? By another telescope.
Yeah, the Spitzer Space Telescope looked at it way back in 2006. It's another infrared telescope.
So what did Spitzer see?
Spitzer saw this twisted structure, kind of like a tornado, and that's where the nickname cosmic tornado came from. It could see the heat signature from all the shocked gas and dust.
So it picked up on the heat, but not as clearly as Webb.
Exactly. Spitzer couldn't see everything. There was this blurry object at the very end of the outflow that nobody could really figure out. It was like a big question mark.
And that's where Webb comes in to really blow our minds.
Oh, yeah, big time.
So let's compare, right? We have images from both telescopes to work with here. We got Spitzer's version and then the pictures that Webb took using its NIR cam and MRI instruments.
Yeah, side by side, it's amazing, night and day.
What's the difference, like in plain English?
So with Spitzer, you just get these fuzzy outlines, like a blurry photograph.
Yeah.
But Webb is crisp. You can see every little detail, the hot gas, the dust, how the jet is interacting with the surrounding material.
So Webb took this blurry mess and turned it into a high-def masterpiece.
Exactly. It's like upgrading from an old tube TV to a 8K OLED.
And that blurry blob Spitzer saw.
Well, Webb revealed that it's actually a whole galaxy.
No way. A whole other galaxy just hiding there.
A distant spiral galaxy. And not only that, Webb also captured a whole bunch of even more distant galaxies in the background. It's like a cosmic Where's Waldo.
Oh, that's so cool. So this is where the real power of Webb shines through, right? It's not just about pretty pictures.
Right. This extreme level of detail gives scientists so much to work with. They can zoom in on the structure of these jets, see how they're being shaped by the environment.
So it's like getting a front row seat to how stars are actually born.
Exactly.
Okay, so back to Herbig-Haro 4950. We know it's this glowing cloud formed by these crazy jets. Where is it exactly in space?
It's about 625 light years away from us.
Okay, so pretty close, cosmically speaking.
Relatively close, yeah. It's in the constellation Chameleon, part of this cloud complex called Chameleon the Three.
Which is a stellar nursery, right? A place where stars are born.
Yeah, it's teeming with new stars, mostly small ones, like our sun.
So by studying this object, we might learn something about how our own solar system came to be.
Potentially, yeah. It's a fascinating thought.
And those outflows, they're moving pretty fast, aren't they?
Oh, yeah, incredibly fast. We're talking 100 to 300 kilometers per second.
Whoa, so not just a gentle breeze.
Definitely not. It's a cosmic hurricane. And that range in speed, it probably means different parts of the outflow are moving at different speeds.
So there's a lot going on there, a lot of complexity.
A lot of action, a lot of chaos, a lot we're still trying to figure out.
Now, Webb's not looking at the universe in the same light that we see, right? It's infrared. What's it actually picking up in this image?
Right, it's seeing heat signatures. Infrared light allows it to see through the dust that would normally block visible light.
So it's like it has X-ray vision for space?
Kinda, yeah.
So what are its instruments seeing specifically?
So NIRCam, which sees in near-infrared, and MIRI, which sees in mid-infrared, are picking up the glow from all sorts of stuff. We're talking excited hydrogen molecules, carbon monoxide, even tiny grains of dust that have been superheated.
So that's what those amazing colors represent.
Exactly. It's not the actual color, but a way of showing the different types of infrared light Webb is detecting. The orange and red, that's the hot stuff, the really energetic molecules and dust.
Okay, so those colors are like a code that tells scientists what they're looking at.
Exactly. And by looking at how bright the different colors are, they can figure out the temperature, density, all that good stuff.
That's amazing. They can basically take Webb's measurements and reconstruct what's happening inside the outflow.
They can even build 3D models of it. It's incredible.
Now, the articles we've looked at mention these arc-shaped features in HH 4950. They compare them to the wake of a speedboat.
Oh, yeah, that's a great visual.
So how do those form, those arcs?
So those are actually shock fronts, where the superfast jet is colliding with the slower-moving gas and dust. And because they're curved, they act like arrows, pointing back to where the jet came from.
Like tracing a ripple back to the stone that was dropped?
Perfect analogy again.
And the source of those jets, that's probably a young star called Cedarblad 110 IRS-4, right?
Right, or CE 110 IRS-4 for short.
And that's located about 1.5 light years away from the brightest part of HH 4950.
Yeah.
What kind of star is that protostar?
So it's what's known as a Class I protostar. It's basically a baby star, just tens of thousands to maybe 1 million years old.
Yeah.
Still growing, still pulling in material from a disk of gas and dust that surrounds it.
So it's like it's got its own little buffet snacking on all this cosmic material.
Yeah, and it's this feeding process that leads to those powerful outflows. It's messy, like a baby learning to eat.
That makes so much sense. Now, there's one part of this outflow that's kind of puzzling, right? This puzzling outcrop. What's the deal with that?
Yeah, it's this weird feature where not all the arcs are pointing back to the same spot.
So it's like some of the ripples in our pond are going in the wrong direction.
Exactly. So there are two main theories about what's going on. One is that it's actually a completely separate outflow from a different young star, just happening to line up with HH 4950 from our perspective.
Ah, so another cosmic coincidence.
Right.
In the other theory.
The other idea is that the jet from CE 110 IRS-4 isn't always smooth and steady. Maybe it comes out in bursts or changes direction over time. That could explain why the outflow looks so messed up.
So either it's a case of mistaken identity or the jet is just being really chaotic.
Yeah, pretty much. More data will help us figure it out for sure.
It's cool though, right? There are still mysteries to be solved.
Definitely. And that's what makes science so exciting.
Okay, let's talk about the elephant in the room, or rather, the galaxy in the outflow. That distant spiral galaxy. What do we know about it?
So it's a face-on spiral galaxy, meaning we're seeing it straight on. That gives us a clear view of its structure, those beautiful spiral arms.
Right, we see the whole thing. And it's much farther away than HH 4950, right?
Oh yeah, way farther. We can tell because we can see other galaxies behind it.
So it's like it's layered on top of the other background galaxies.
Right, and it's got this bright central bulge, which looks blue in the Webb image. That's a sign of older stars.
Older, so they've already burned through a lot of their fuel.
Yeah, and the bulge has these interesting side lobes, which suggests it might be a barred spiral galaxy.
What's that?
A barred spiral galaxy is a type of spiral galaxy with this bar-shaped structure of stars and gas right across its center.
Huh, interesting. And the reddish clumps in the spiral arms, those are star-forming regions, right?
Yep, lots of baby stars being born in those areas. Yeah. It's kind of like a mini version of our own Milky Way, but billions of light years away.
Incredible. And the article even mentions that this galaxy has these empty bubbles in its dusty regions, similar to what Webb has seen in other nearby galaxies.
Yeah, that's the PHAS program.
So even though these two objects, HH 4950 and this distant galaxy, are completely unrelated and super far apart, Webb is showing us that they're governed by similar processes. It's like a cosmic connection.
It's pretty amazing, right? This whole image is basically a cosmic coincidence.
Yeah.
We're just lucky enough to be looking in the right direction at the right time to see it.
It really makes you think about how much is going on out there that we just don't see.
Totally. And remember, this alignment isn't going to last forever. Over thousands of years, the edge of HH 4950 is going to move, and eventually it's going to cover up the galaxy completely.
Wow, so we're witnessing a really special moment in time, this fleeting alignment of these two incredible objects.
Exactly. And it highlights the dynamic nature of the universe. Nothing stays the same forever.
So big picture, what have we learned from this deep dive, this incredible image from JWST?
Well, first of all, it shows just how powerful Webb is. We went from a blurry blob with Spitzer to this incredible high-definition view.
We can see the details of star formation in action, this intricate dance of gas and dust.
And it's not just seeing further, it's seeing better, understanding more.
We learned about these amazing Herbig-Haro objects, these cosmic tantrums of baby stars.
And we even got a glimpse of a distant spiral galaxy, a whole other island of stars billions of light years away.
And it's all thanks to this crazy cosmic coincidence, this alignment that allows us to see both a nearby stellar nursery and a distant galaxy in the same shot.
It's like looking through a keyhole into the vastness of the universe.
So what should our listeners take away from all this?
I think the biggest takeaway is that what we see in the night sky isn't always the whole story.
There's so much more going on than meets the eye.
Exactly. Our brains tend to simplify things, flatten them out.
We see a flat image, but the reality is so much more complex, so much more three-dimensional.
And this image, with its seemingly impossible alignment, really makes you think, how many other times are we seeing these chance superpositions? How many objects that look like they're right next to each other are actually separated by immense distances?
And telescopes like Webb, they're the tools that help us untangle these cosmic illusions, right?
Exactly. They allow us to see through the foreground, to understand the true relationships between objects in space.
To build a more accurate picture of the universe.
And who knows what other cosmic illusions are out there, waiting to be discovered. What other seemingly impossible alignments will reveal even more secrets about the universe?
That's a great question to ponder, and it makes me so excited for all the future discoveries Webb will make, all the ways it will continue to change our understanding of the cosmos.
Me too, me too.
So until our next deep dive, keep looking up, keep exploring, and never stop questioning what you see in the night sky.
You never know what you might find.